21.
21. And Nayeli? Data entry. Good morning, guys.
Good morning.
Morning, good morning, morning. Oh, dark in here. Let's fix that, shall we? Okay. I'm barely awake. How are you guys?
Me too.
Yeah. It's rough today. Can't get my Okay. So number 21. No, this was yours. Was this the 7x cubed?
Yeah.
Square root of x to the fourth plus 6?
Mm-hmm.
Okay.
Execute it.
Is it pretty, guys?
No.
Can we make it pretty? How?
7x to the fourth plus 6 in brackets, and it's going to be 1 over 4. 1 over 2.
Where'd you get the 4, Maria?
Oh,
Good morning. So everyone cool where the 1/2 came from?
yes.
Great, fine. What's your U?
X to the 4th plus 6.
X 4 plus
Yeah. What's your prime?
4x cubed.
4x cubed. And what do you have?
7x cubed.
And what do you want?
4x cubed.
So what are you going to multiply and divide by?
6 by 4.
Don't overthink
4x
it.
cubed?
Just 4. You have the x cubed, right?
Oh,
X cubed is
okay.
already set. So all you can mess with is that constant coefficient. So we're just going to multiply and divide by 4,
Okay.
right? So if I do that, what am I going to keep and what am I going to take out?
7 upon 4 is 12.
Right, I need the 4 and I need the x cubed. So I'm going to keep that. And I'm going to kick out the 7 and I'm going to kick out this 4 down here. So I'm going to get 7/4 integral 4x cubed x to the 4th plus 6 to the 1/2 with respect to x. Right, guys? Memo, can you take it from here?
Yeah.
Groovy.
Okay.
Does it make sense, guys? Awesome. All right. So let's look at number 25. Oh, I did this accidentally. So who asked for this one? Nikki? Yeah, there's a reason. Actually, it's not accidental. Yeah, it's not accidental so much as I didn't intend to give it to you, but it's okay that I gave it to you. So let me talk you through this sucker. So this is 3x to the 4th minus 1 quantity squared times 12x dx. Right? So Nikki, your first inclination was to treat this like integral number 2. U is 3x to the 4th minus 1. U prime is 12x cubed.
This is 25, right?
Yeah, this is 25. But you can't do that, right? And that's probably why you got stuck. So U is 3x to the 4th minus 1, and U prime is going to be 12x cubed. But this is what we have, guys. We have 12x. So what would we need to multiply by to get 12x cubed? X squared. But what did I warn you guys about? Can't do that. You can't multiply and divide by a variable because then you have to integrate it if you pull it outside of the integral. So instead, you guys are going to hate this, you have to FOIL it out and integrate it using integral number 1. So over to the side here in black, I'm going to do 3x to the 4th minus 1 times 3x to the 4th minus 1 times 12x. So this is the actual function that we're integrating. So I'm just going to FOIL it. So I get 9x to the 8th minus 6x to the 4th plus 1, all times 12x. Now I'm gonna distribute that 12. So I get 108x to the 9th minus 72x to the 5th plus 12x. And now I can integrate this with respect to x. And we'd be using integral number 1.
So you wouldn't just leave it at that?
No, this is integrable, just not by method number 2. It would be method number 1. Now, if this were any higher, if this were like a power of 3 or 4 or 5, I wouldn't do that to you guys. That's nasty, that's just mean. Because then you'd have to FOIL that out the whole way and then integrate it, and that's just a nightmare. So instead, recognize that sometimes the power rule doesn't work. Here's the gut trick, guys. What's the power in u? It's 4. What should the power in u prime be then? What do we always go down by when we take a derivative? We go down by 1, Sam, that's right. So if this is 3x to the 4th, this should be some x cubed, right? So if you don't have that, then immediately power rule falls apart. You can't use integral number 2. Good morning. Any questions on that one? Memo? You look unhappy. What's up?
I guess I just lost like my place, but
That's okay.
here. So now it's just time to integrate, that's it?
Yeah, it's just, this will be 108x to the 10th over 10 minus 72x to the 6 over 6 plus
Oh, okay.
12x squared over 2 plus k.
Okay.
Yeah. Do you guys need another second to stare at that one?
Because in question 5A,
Yeah.
the problem came up and we stopped us not working this. But in question 25, we go further into it.
Right, well, okay, so in question 5A, there is no 5A.
Is that 12 times?
I'm on 12.2.
Yeah, 12.2.
There is no 5A.
There's 5, but in 5 there are 2 sections, A and B, and we have to.
Not my capsule, can I?
So this one is plus 1? Goes to the 1 over 1? Or square?
Oh, this is just
Oh.
essentially the same problem. So yours may be number 5, but look at this, it's just essentially problem number
Yes, and
25
yeah.
that we're doing
But my
now.
question was on
And then
that
you
one.
put it this side here as well.
Yeah, on this guy. Usually it's,
Squared, it would
Yep.
be.
there's a 1, right? So if you add a 1, it's a square,
You can't
right?
FOIL this out.
Okay, it's a
There's
2.
no way you can FOIL the power of 12 out. But here you can FOIL it out and integrate.
And I'm sure you can reduce some of these, right? If you really wanted to.
Reduce what?
These big numbers.
Oh, the numbers here?
Yeah.
Yeah, because you could divide each one.
Yeah.
So this one would be divided by 10, so 10.8. This would be divided by 6, so 12.
Mm-hmm.
This would be divided by 2, so 6.
Okay.
Yeah, so they would just simplify that way. Maria, come find me. That's probably one we're gonna have to tackle in the office. Okay. Keenan.
Did you say you used the first integral?
Yeah, I used integral number 1. I found that integral number 2 failed because I couldn't multiply this by x squared over x squared to get what I wanted. This fails, yeah, so integral number 2 falls apart. So
I need to
instead,
finish that one.
I FOIL the whole
She
damn
just
thing
kinda
out and
left
use
it
integral
in
number
the
1.
You know how to-
Does that make sense? Okay, so sometimes that's doable. When the power gets really high, this n, when this power gets really high, that's not possible. There's just no way in hell you're gonna FOIL all that out. Yeah.
She didn't finish it.
Yeah, but like, what are you supposed to do?
Oh, sure.
All right, so now, on my eraser.
Then you're gonna actually integrate, and this is weird because you go like, where's your pencil?
So now, let's do that data entry problem.
But that was for
Data entry speed. The rate of change in data entry speed of the average student is ds by dx, and I'm gonna write it the same way they
Plus
have it in
one.
problem.
Plus two, over
Is
two,
your type
over
x plus one to the negative 1/2.
two.
Okay, so let me finish writing this, where x is the number of lessons the student has had, and s is an entries per minute. So s is entries per minute. And x is number of lessons. We read further and discover that we're supposed to find the data entry speed as a function of the number of lessons if the average student can complete 10 entries per minute with no lessons. That's your nugget, guys. 10 entries per minute with no lessons. So what does that mean? So when x equals what?
0.
Yeah, when x equals 0, s equals 10. This is your nugget. Questions?
So this is the.
Why is it 0 or not 1?
Because it's what it said, Saeed.
I
Let
was,
me read it one more time.
this was the same problem.
It said,
we had
find the
with research.
data entry speed as a function of the number of lessons if the average student can complete 10 entries per minute with no lessons. No lessons. So s is 0, or sorry, yeah, x is 0 because x is number of lessons, and then 10 entries per minute. Agree? So let's integrate it. Because it wants us to find entries per minute. So s is going to be the integral of 5 times x plus 1 to the negative 1/2 with respect to x. Any questions about how I set that up? All right. So which integral are we using? 1, 2, 3, or 4? 1. Okay. How do I use 1?
You just put 5 on the outside.
I could, but 1 requires just x's to powers. This is x plus 1 to a power. So which integral is it really? It's number 2. So what's my u in this case then, guys? X plus 1, and what's my u prime? 1, and what do I have? I have a 5, and what do I want?
1.
And when do I want it? So what do I multiply and divide by?
Nothing. Just 1 or 1.
That's right, because if I yank the 5 out, what's left over?
1.
The one that's always sitting there. You guys cool with that?
Cool.
Okay. So, let me rewrite this as 5 integral 1 x plus 1 to the negative 1/2 with respect to x. Do I have u prime u to the n? What's my integral? 5 goes along for the ride, u to the n plus 1 over n plus 1 plus some constant associated with speed, or entries per minute. So I'm going to go ahead and simplify this just a tiny bit. I'm going to invert this and multiply, so the 2 is going to come up and become a 2. Is cool with that? I'm also going to make this a square root. Why? Because it's easier that way. Trust me. X plus 1. You'll see why in a second. Okay. So now I have this function, but it's incomplete. I need to solve for k. So what am I going to do now? Christina?
10 for s.
Plug in 10 for s and what for x? 0. Okay. So now I'm going to do that in blue to correspond to my nugget. So 10 for s equals 10 square root of 0 plus 1 plus k sub s. So what's 0 plus 1, guys? 1. And what's the square root of 1? 1. And what's 10 times 1? And what plus 10 equals 10?
No,
Good, so what does k sub s equal?
no.
Good, you must go through the motions. So my real true function, guys, is going to be s as a function of x is 10 times the square root of x plus 1. Done. How do you guys feel? Yeah. Not bad, right? Saeed, how you doing? Yeah?
Always good. Thank you for asking.
Yeah, no worries. Sal, how you doing? Just okay.
On the answer, this is 50.
What?
This is the answer for B, for the part B, this is 50.
Well, I haven't done part B yet. So let's get to that. That sounds like fun. Part B, how many entries per minute can the average student complete after 24 lessons? So what am I plugging in? X equals what?
24.
24. So when I plug 24 into this, I get 25 under the square root, which is what? 5, and 5 times 10 is. So after 24 lessons, they can enter 50 per minute. Does that make sense? Awesome. Yeah.
I got the same, like 50, but I just wrote it as 10 times x plus 1 to 1/2.
That works. Yeah, you can totally keep it in the 1/2 power. Do you know how to do that in your head? I don't. So you entered it into your calculator, right?
What do you mean by?
I mean, like, can you solve that in your head? What 25 to the 1/2 is? I mean, the reason I'm asking is I don't think in terms of powers of fraction. I think in terms of square roots. So it's totally reasonable to do it like this, to solve it from here. But in my head, if I convert it back to its simplest form, I can do this in my head with no calculator required. So it's perfectly fine to do it with your calculator, but in my brain, it makes sense to do it like this. But go with whatever floats your boat, Elena, basically is what I'm saying. You can get your 50. You can do it using the 1/2 power. It works just fine. Any other questions on this one? What was the hardest part? Those of you that tried it. Which I'm assuming is few of you. How many of you got this far? Okay. All right. How many of you are just a little bit behind on your homework?
I don't know if it's a little.
Okay. Test 2 is next week, guys. It's next Thursday. This is not a class you want to cram in. It's just not. You will be sad. Just telling you right now.
Is it a group test or?
No, it's not the group test. Test 3 is the group test. So again, this is not a class you want to cram in, guys. All right. Here we go. Today we finish up the first 4 integrals, or the only 4 integrals we learn. And we finish up chapter 12 on Thursday. And then all we have left is 6 lessons after that. That's it, guys. 6 lessons after Thursday. That's it. I mean, there's a lot more to it. There are review days and test days and review days for the final and then the final exam. But there are only 6 more new lessons after this Thursday. So, again, not a class you want to fall behind in. So, here's what we've learned so far. Today is 12.3. Integrals of logs and exponents. And what we know so far are these 2 integrals. X to the n with respect to x becomes x to the n plus 1 over n plus 1 plus k, and n cannot be negative 1. We also know u prime u n with respect to x becomes u to the n plus 1 over n plus 1 plus some k, and n cannot be negative 1 once That's, dear God, you guys. Good morning. And n cannot be -1. Today, we're gonna pick up the last two, which are e to the, whoops, u prime e to the u with respect to x becomes e to the u plus k. Notice there are no requirements on this one, so you guys should all have your tattoos out.
Looking at this.
Next to you, just hanging. Russell, Russell, Russell.
Can I ask a quick question? Can we do the tattoo plus a cheat sheet?
Yeah.
Okay.
Yeah, tattoo plus cheat sheet on the exam. Like literally, guys, I've set it up for you. The only person that can, well, anyway. All right. So, and the last one is u prime u to the -1 with respect to x, which becomes the natural log of u plus k. And in this one, u must be or the n must be -1. N must be -1. It must be. So I want you guys to notice that integral number 2 and integral number 4 look really similar. What's the only difference? Just the setup for them. What's the only difference? N. Here, n cannot be -1. Here, n has to be -1. Do you guys see that? Okay, so whenever you get a -1, it's a natural log. Okay, that's it. Your exponent is -1, it's a natural log. Unless you have some e to the u. Remember, there are no restrictions on the e. So process of elimination lets you know which one you're looking at. If your base, it's all about the base, guys. If your base is x, it's integral number 1. If your base is u, it's either gonna be integral number 2 or integral number 3. And then you look at the exponent, the -1 decides which one it's gonna be. If the base is e, it's integral number 3. Sorry, this should be integral number 2 or integral number 4. Sorry about that. So let's take a look at some. La, 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 la. Good times. Which integral is this? Why? Has an e. Don't overthink it, guys. So what's my u? Based on this, u is the exponent. It is the entire exponent. So it could be a power, it could be a simple function, it could be something, but u is the entire exponent. So what's my u here?
5x.
What's my u prime?
5.
And what do I have?
2e.
And what do I want?
5.
Yeah, I have a 2 living where u prime needs to live, and I want u prime. Always want u prime. So what am I going to multiply and divide by?
5.
5. Good. Keep what I want. Take out what I don't. So I want the 5. I don't need that 2, and I don't need that 5. So I get this. You guys are going to figure this out real quick. We're just doing the same exact flipping thing over and over and over again. The only thing that changes is the type of integral. But that stuff's just plug and chug. Because once you've got u prime, you just fill in the blanks, right? So this becomes 2/5 integral 5e to the 5x with respect to x. And I have exactly u prime e to the u. What's my integral, guys?
2/5.
Look at the template.
E to the 5x
Thank you.
plus k.
And we're done. Some of you are saying, where the hell did this 5 go? Raise your hand if that was in your brain. Okay, so I want you guys to remember what happens when we have some e to the u. you, look at your tattoo,
Like, you work
look at
so hard for
derivative
it.
number
You
3.
don't even use it.
U prime pops up when you take the derivative. It disappears when you integrate. So on derivative number 3, you go from e to the u to u prime e to the u. So when you integrate, that u prime is gonna disappear and you'll end up back at e to the u. You guys with me? So we're just completing that circle. You wanna try another? Yeah. Which integral is it, 1, 2, 3, or 4?
Same thing.
Great. What do we have? Sorry, what's u prime? First of all.
Negative 3x.
Yeah, u is negative 3x, u prime is negative 3. I can't write sideways, apparently. So I have 4/5. I want negative 3. So what am I gonna multiply and divide by, guys?
Negative 3.
Can I just multiply by negative 3 and divide by 3? No. Why not? What's negative 3 divided by 3 equal?
Negative 1.
Negative 1. Can I just multiply by negative 1 and expect everything to stay the same?
No.
What's the only thing I can multiply by? Negative 3 over negative 3, or in other words, positive 1, right? We cannot alter anything, guys. Crap, let me erase this one. Okay, so this would become negative 3 over negative 3 times 4/5 e to the negative 3x with respect to x. Keep what you want, kick out what you don't. So what's outside, guys?
4 over, or negative 4/3? Or 4/15, yeah, you're right.
Negative 4/15. Integral negative 3 e to the negative 3x with respect to x. So now I have everything I want. What's my integral?
4/15 e to the negative 3x plus k.
Negative 4/15 e to the negative 3x plus k. And we're done. The hardest part here is making it look like the template, okay? I am following the same steps that are on your tattoo. Make it pretty. Which integral is it? Find u, create u prime. We have, we want, make it look like the template, and then integrate, okay? I'm following those steps. Do not skip any steps. Don't skip steps. You'll be sad if you skip steps. Don't skip steps. Are you gonna skip steps?
No.
Okay, awesome. Let's try another one.
Can I ask a question on this E day is, why do we have E in general? I know what it is, the Neperian number.
Why do we have E in general? Because it describes a lot of exponential growth. Remember, E looks like this. So when you have exponential growth functions that don't cap out at something, then we incorporate E. Does that make sense? Okay. All right. So how about this for funsies? Ooh, they're so good.
Can I ask a question?
Absolutely.
You answered this before, but I just didn't understand. Where does the minus 3 go? Why does it go away?
This?
Yeah.
So look at your tattoo, look at derivative number 2, or sorry, number 3. So when you have e to the u and you take the derivative, it's u prime e to the u. So u prime pops up when you take the derivative. And since the integral is undoing what the derivative did, what do you think is gonna happen to u prime when you integrate?
Oh, that's
It's gonna go away. Yeah, pops up when you take the derivative, disappears when you integrate. Okay? All right, how about this one? uptown. What do I bring uptown?
The denominator.
The denominator. How do I do that, Memo?
You just do x minus 3 times x squared minus 6x plus 1 to the negative 1.
That's right. It doesn't have a package to travel in, guys, so give it one. Wrap it before it goes on vacation uptown. When you bring it uptown, the sign changes. This becomes x minus 3 quantity times x squared minus 6x plus 1 to the negative 1 with respect to x. Which integral is this? 1, 2, 3, or 4? Careful. What can n not be in 2? Can't be negative 1. So which one is it? 4. It's the only one where you can have negative 1 as your exponent. Anne Marie, you're good? Yeah, okay. All right, great. So what's my u?
X squared minus 6x.
Plus 1.
Nayeli and Maria had it. U prime is?
2x
What
minus
do we
6.
have where u prime needs to live?
X minus 3.
And what do we want? Always u prime. So what do I need to multiply by to get 2x minus 6?
2.
And if I multiply by 2, I must also divide by 2. Circle what you want, kick out what you don't. So I need all of this to get what I want. And I don't need the 2 on the denominator. So if I rewrite this sucker, I get a 1/2 out front, 2x minus 6, if I distribute that 2, x squared minus 6x plus 1 to the negative 1 with respect to x. What's my integral, guys?
1/2 times x squared minus 6x plus 1 minus 1. Or, not minus 1.
Look at integral number 4. Emma.
Oh.
You're working on integral number 4. So never do it from memory,
Oh,
always
yeah.
trust your tattoo.
Okay.
That's what it's there for. So I heard a whole bunch of people say it. Natural log of u.
Yeah, you're right.
So my u is x squared minus 6x plus 1 plus k. Now, in your book, it does a couple of extra things that I don't do in this class. So for example, this is gonna be an absolute value in your textbook. We don't need the absolute value, guys, because we never shove in negative x. We just don't, okay? So we're never gonna get some negative result out of this. So far, so good? We're just not. But just FYI, the proper math is this would be an absolute value of the natural log, okay?
Natural log can't be negative, can it?
No, you can't have a negative input into the natural log. We talked about that when we introduced natural logs. Yeah, so that's why it gives an absolute value in the integral. All right, questions so far?
How did we get minus 6? Oh, I got it.
You're good? You sure?
Yeah.
Okay. All right. You guys wanna try another?
Yes.
All right, it's not gonna be pretty.
Yeah.
Just warning you now.
Dad makes that joke like every single day.
You're gonna hate me.
I look pretty ugly. Thank you, Steven.
You already hate me, that's all good. Fun. Honestly, guys, it's the same thing over and over and over and over again. That's why the steps are set in stone. Some people prefer these integrals because they're so steppy, because there's a set number of rules that you have to follow, and some people prefer the sort of craziness of the derivative where anything goes. So how many of you are integral people? You like this regimented, follow the steps and you'll get it right. How many of you are derivative people? You like to just sort of look at it and figure out where the hell you are. So how many of you didn't raise your hand? Yeah. Okay. So you're just not that kind of person at all? You're neither one nor the other?
That's
Okay.
right.
Okay, so let's look at. Oh, gosh. Yeah, let's do that.
Sounds bad.
So I did this one in class yesterday, and oh God, it was fun to watch their reactions. Is it pretty? Can we make it pretty?
Yeah.
Mm-hmm.
What changes sign when I bring it up?
A negative 4x
Everything.
to the 4.
Yep.
What was that, Emily?
Negative 4x to the 4.
Yeah, okay, so how many say it's this 4 that changes sign? How many say it's this 4 that changes sign?
Oh, isn't it the whole thing?
Everything.
Okay, let me ask you this. If I have 4 over x to the 2, what changes sign when you drag it up? The 2 goes negative. Well, did you know that 2 has a 1 hanging out up here? What happened to that sign? It stayed positive, didn't it? So what's the lesson? What goes negative? Emily had it. Good. So this becomes the integral of x cubed e to the negative 4x to the positive 4th with respect to x.
But the 4 is with the x,
Yeah.
signing with the x.
Yeah, but we're grabbing the exponent of the entire denominator, and when we drag that up,
Oh, I
the
see.
e's gonna come with it, and the exponent is gonna go negative. Not the exponent of the
Yeah.
exponent, just the
Because we're
exponent.
grabbing all of it and
Mhm. Yep, moving it uptown.
Okay.
Okay, so again, this is the one that changes sign. This position right here. Okay, so if you ever forget, just write that down and you'll remember it immediately. Okay, so which integral are we looking at? 1, 2, 3, or 4?
3.
3. Why?
There's an E.
There's an E. That's right. You missed all the good stuff. Uh-huh. Okay, so what's my U, guys? And what's U prime?
16x squared negative.
And what do I multiply and divide by? Yeah, negative 16. So I want negative 16x cubed. I'm gonna take all the elements that make that happen and kick out the ones that don't. So I will get negative 1/16 outside, negative 16x cubed, e to the negative 4x to the 4th with respect to x on the inside. Now I have precisely my template. What's my integral?
Times
Whoops, that's not right. Plus k, not dx. Come on, crack. Teacher crack. Okay. Questions so far? How can you check your work? Take the derivative, exactly. And if I take the derivative, where will I end up?
Back to the beginning.
Square one.
Yeah, hopefully it's square one, because if you don't, what you did was, here's the derivative, and here's the integral. You don't wanna do that. You wanna end up precisely right back where you started, and that's why we follow these steps, guys, is so we can complete that circle. Questions so far? All right, I'm gonna give you guys a really tough one to work on over amongst yourselves. And I'm gonna walk around and help you guys. I'll give you a little hint to get you going. This one's straight out of the textbook.
bracket things. They're annoying and hard to do.
What are you talking about? They're like those things that hang on the Christmas tree. The little one. I like it.
That's beautiful. Beautiful symbol.
It's getting toward that time of the year.
Personality, pride, Eve of Christmas. X. Why would you do that?
All right.
Dad, you can't leave your behind.
Work together, work apart. That's what happened.
Okay, so we have u, which is 3x squared, u prime, which is 6x. Okay, so then this becomes,
One at a time.
we're doing this half? I just don't understand like where these brackets go.
It's just.
This is what we want, right?
Yes.
Want. This is what we have right here.
It's just 1x.
Have.
So we need to move 6 over 6.
Divide by 6, right? So we're gonna do.
I just
We're
don't
gonna do.
understand these bracket things.
You're gonna put the bracket again. You're gonna put the thing again. And then you're gonna do
What is it?
6. And then you're gonna do times x over times. Just a little dot. X over 1. Always a 1. 1x.
And then is it
And then e. And then yeah. Keep it on top. Yeah.
squared? Okay.
Plus
so
dx. So now try to now circle what you need. Take out what you don't.
Okay. So what I think is gonna happen?
So now,
1 over 6.
now when you rewrite it, you don't
Is it like that? Because this goes
yeah.
out.
Yeah. You write your little bracket again and now.
6x gives me squared dx, and then just becomes
You're killing me.
xe.
Why didn't you tell me you were so good at this?
I'm not. If I was by myself, I would really start crying right now. Because of this.
Okay, so you got this.
On your top two.
Okay. And now you're now the bracket's gone. Now it's y. This is the now you're gonna take your right. Y equals 1 6. So this goes away. This is the derivative. 3x squared
Okay.
plus. Hey, wait, no.
For that one.
Okay, you have to wait
I
till
know, that
end,
one's
right?
What was the rule for this? Where are we?
Where does X go?
What was the rule? Huh?
Where did the X go?
It was a 6x. It was a 6x.
So where did it go?
It disappeared.
Okay.
See, look, that was this one. That was this guy. The derivative. The derivative disappears when you take the integral. So you just rewrite the code that goes along for the right.
3x squared.
When you write it, it's 1 6 because this goes along for the right. This is 1. And then this. Because we're looking at this rule.
Yeah, but then for this problem, you don't put plus into the end, yeah?
No, because look, this rule doesn't require you to do that. And you're doing integral number 3 because it has a
Yep,
Okay.
so then the derivative becomes really easy,
Okay, so
right?
then it's 5 over,
So otherwise, you're in good shape, keep it up. Justin, how do you? Good. Did I see another hand? Did I see an, Keenan.
why do you, just have X?
So this one's crazy because we first had to rewrite it to make it pretty.
Okay, so I just sort of did it in really tiny
And
letters.
this one is going to be
So negative x over 3, you will write as negative 1/3 x. Right, so always write that constant out.
Did Brenda give you your pen back?
no, I haven't asked her. She hasn't.
Yeah, because they will eat you. By the way, you guys, this is harder than anything you'll see on the test, but there is one of these on your homework, and I do want you to do it. That's why we're
How do you
pushing through right now.
you find it?
Somewhere here. Let me see. Which one did we split it into?
Yeah, this is the.
Oh. Okay. So negative when we rewrite it. It's,
Negative 1/3.
yeah, it's the same. 'Cause there's always a 1. There's always a 1. Negative 1/3. That's right. It was basically negative 1/3 x, but the u prime is negative 1/3. Okay.
So we want this, we have this.
We have negative 5. So what are we going to multiply?
Negative?
Oh, maybe on her problem it was. Yeah, it was.
It's not. Oh,
Yeah, it was.
I guess. But I'm saying so, we have.
We have negative 5. And we want negative 1/3. Right?
I have no idea.
So don't overthink it. Just multiply and divide by negative 1/3.
Yeah, but you can't. That doesn't make 5.
It doesn't have to be 5.
Yeah, it does.
No, because we don't want 5. We want negative 1/3.
Okay, what am I writing right here? Negative 1/3 times 5.
All right, how many of you are stuck and hating life right now?
I'm always stuck in anyway.
All right, good times. Let's do this. So I told you guys you can split them up, so that's the first thing I'm gonna do. I have x e to the 3x squared
I didn't write
minus
this stuff that we're writing for some reason.
integral, oops, sorry, with respect to x, minus 5e to the negative 1/3
You
x.
have to multiply and divide.
dx.
Whatever you do, you have to multiply and divide.
Okay, does everybody see where I got the negative sign up here?
What do I want?
Bring it up, change the sign. Does everybody see how I became, or how I went from negative x over 3 to negative 1/3 x?
Negative 1/3, I think, over negative 1/3,
Yeah.
and then times
So
by
I wrote it over here, and I'll rewrite it in brighter, bigger letters.
We'll see what she
We'll
says.
see.
That's the same thing, guys. So at this point, you should be thoroughly familiar with this kind of algebraic manipulation. Okay? So now, we're gonna tackle the u's and u primes separately. So what's my first u?
3x2.
3x squared, and my u prime is 6x. I have x, I want 6x, so what am I gonna multiply and divide by on this guy? 6, so I'm gonna have 6 over 6, x e to the 3x squared with respect to x. So this one's sort of set up. Now let's go on to this one. What's my u? Yeah, what's my u prime? Negative 1/3. So I need a negative sign and I need a 3. I don't care that it's a 3 on the denominator. So So here's what I'm gonna multiply and divide by. So my negative comes down, integral -3 over -3 times 5e to the -1/3 x with respect to x. So watch really carefully, guys. I need 6x over here. So I'm gonna kick out the 6 out here. How many of you got that far? Made a 1/6. Okay, good. Now, what do I need over here? I need a negative, an x, and a 3 on the denominator. So here's my negative, I need a negative and a 3 on the denominator. So here's what I circle. It's not that. It's this and this 3, or alternatively, and my favorite, I can just circle this guy. So this is a -3 up top. And I'm just gonna kick it out. But I'm also gonna kick out that 5. Okay, so watch this. So now I have 1/6 integral
So keep
6x
the -3,
e to the 3x squared.
and then it'll make a 1 on top.
I bring out, what's -3 times 5? What kind of 15?
Negative.
Negative, and when I drag it out, it's gonna multiply by that negative, making it positive 15. Watch your signs, guys, they will eat you alive. So now I'm set up to integrate. Okay. Questions about that? Yes, Sal? What? Okay, so you see that this becomes -15, right? So when I drag it out, it's multiplied by that negative. So negative times this negative makes it positive 15, okay? Leaving this negative inside to make -1/3. Questions?
I'm sorry, I'm just a little confused on how did we get -3 over 3? If,
It's not -3 over 3, it's -3 over -3. The
or yeah,
reason is,
-3 over negative.
I decided I needed a 3. I don't care if I keep the numerator or the denominator, I need a 3.
Okay,
Okay, so if I multiply and divide by -3, I can keep the 1 on the denominator. No one said I had to keep the numerator 1. I want the denominator, because I want 1 over 3. So I'm gonna keep this one, and I'm gonna keep the sign, because that makes it negative, and that makes -1/3.
okay,
There's a hidden 1 here, guys. There's always a hidden 1 up top. Just like when you drag a 2 out, Gesundheit, when you drag a 2 out on the denominator, you just plunk a 1 on top to hold it there. You guys don't think twice about that. So when you drag everything out and leave a 3 on the denominator, plunk a 1 on top to hold it there. Same thing. Okay?
okay.
So what's
I
my
understand.
integral, guys? Oh, wait.
So you had a -1/3, and you had a 5 up there, so you want a -1/3,
Mm-hmm.
and so what you did was
Gesundheit. What I did was what? I'm sorry, Maria.
to get 3 on the top, in the numerator, it's like probably, you just,
Talk to me.
I can't seem to put my head around the -3 in the numerator.
Ah,
I can
okay.
see the denominator being -3.
Here's what I did. I decided I needed a negative and I needed a 3 on the denominator. So if I multiply by -3 over -3, I can keep this one, and that gives me the elements I need.
No, I understand the
Here.
denominator being -3, but I don't know why, I can't put my head around the numerator, -3.
Okay, I can only multiply by 1. That's it.
Okay.
But I can make 1 look like whatever I want.
Okay.
So if I need a -3 on the denominator,
Just
I
automatically.
better put a -3 on the
Okay, so-
numerator.
okay.
It's always the same number.
Okay.
Always, always, always. Keenan, and then memo.
So you said that you can keep either the numerator or the denominator?
Yeah. Depending on what I need, yeah, because it's flexible. Multiplication and division are the bendiest bits of algebra.
'Cause it used to
They
be
can go anywhere,
-5.
they can do anything.
And
Okay.
that's-
Memo and then Emily. Sorry, Memo.
I think it's the same question.
Okay,
You
what's
got
up?
rid of the negative?
For
Like
what?
you moved it
Yeah,
to the other
I
side?
kicked it out. So I made this a negative 15, and then I dragged it out and made it a positive 15.
Then why?
Yeah. Negative times a negative is a positive 15.
But then why is there a negative out there?
Because the name.
This negative downtown
negative.
stayed with this.
But like, why is there on the outside of that bracket? Why is there just a negative sign?
Because of the nature of the original statement.
I got you.
I had that negative and I just left it out here.
Right.
What if you
Okay.
kept it in, would that be a problem?
No, but you have to keep your signs straight, guys. If I made this plus a negative 5, then it would still work out. You would still have a negative 3 times a negative 5, and this would be a plus out here, right? What's a negative times a negative? A positive, and when you drag it out, this would have been positive, so it'd still be positive 15.
So when you're doing the integrals and the dividing, you just make sure that your integral
You have to keep,
I've missed some
before
obvious
the
things.
sign.
you have
should
to
have
keep
just
your
copied
negative
out.
signs straight,
That's all
is
for
what
that.
I'm saying.
Like
You have
the
to be
stupid
really
number.
careful about this.
Well,
This
you
is
read
why I
it.
want you guys to write really big, so you don't lose stuff, right? When you write really tiny, you lose stuff, don't you? You forget things. They get smashed together and they get lost. Saeed, did you have your hand up? Okay,
Not yet.
not yet?
Is the end answer,
Have to integrate.
Ah, we still have to integrate it, guys. We're not quite there yet. But it's easy, it's plug and chug. 1/6 e to the 3x squared plus 15 e to the negative 1/3 x plus k. And we're done. The hardest part was getting it set up. How many of you guys now recognize the power of splitting stuff up so that you can treat each term differently if necessary? Okay, good. Good.
I got the first part correct, the second part I was studying.
Not so much yet.
Minus 1/3,
So you're gonna see this, in your homework. There's gonna be a problem like this in your homework. Just FYI. Watch your signs. That's the best lesson I can give you guys, is watch your signs on this stuff, because it will eat you alive.
Watch yourself.
Okay, now, I think you guys are pretty solid, so I'm gonna let you play around with your handouts. And I want you to stick around and actually work on the handouts today, even though I know you desperately wanna get going. Just hang with me, and we'll work through some of these problems. Get you guys comfy with these. Memo, you have 2 of them now.
Yes.
Sorry, Memo.
No, I don't.
No, you don't?
Okay. I'm confused.
That's funny.
Why?
Yes,
Does this
sweetie
become
pie.
negative 1? Get your handout out.
Dude, I can do it off memory because I'm a gangster like that. Yeah.
Because if you bring this uptown, this has to become negative, but there's like nothing there. It's 1.
You mean gangster? Bust out your hand out. What rule are you using? What rule is this?
Right.
Which one is it?
It's not that one.
Well, it kind of already. You should look at this one. Obviously, you're not gonna find it from looking at this one.
Right, exactly, but that's why I made this. The question
So
is
this one is
this
what
right?
rule? Is this guy?
I don't know.
What do
I
you
haven't
mean?
gotten that far. I just wanna know if this is right. X down.
Oh, because you brought it up. Yeah, of course.
But then it can't be negative 1 for
So then
these.
it
So
can't be
it's
this one. It
this
has to
one.
be this guy.
So then U is 8 next to the 7, which is,
Come on.
is it 56? 7 times 8?
Yes.
56. We have.
So on board, what you're losing is not 6x, or not 6.
We have 1. No.
also counts.
Did you have an
That's why it
epiphany
helps to
today?
come twice. No, that's why it helps to come twice. It
Right.
really does help.
What if you get the gift and start doing the homework? Does that feel?
No, because part of the process of getting a good grade in this class was doing your homework.
What was that?
Part of the work was the last one, must do your homework. That's part of the process. This is not.
Whoa, 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 whoa.
Welcome to college.
You did something wrong. This is not you. This is you. You's always the one with the power.
What has power?
Erase that.
Just like that.
Oh, wait. You're right.
Yeah, right.
Yeah, and it's the one with the highest power, so you're right. I'm sorry.
But this is the highest power.
What's the exponent though?
It's this one.
It's not wrapped for travel, so give it a little wrap, give it some parentheses down here. And what's the power on those parentheses? Yeah.
It's the
So
overall
when you bring it
power,
up, what's the
though.
power become? Your 8x to the 7 is just hanging out. So when you drag this up with that power of 1, what does your 1 become?
Okay, so then this becomes
What happens when we bring stuff up and change it?
Hey, look, this power is equivalent to this power. It's just a little guy up here. But this guy is like above. It's like if this had a thing up on top. This one.
Absolutely.
So it's bigger than this. Even though it's an integer.
exactly. So this is 8x minus 10.
Yeah. So it's good that you erased it. It's good that you erased it. 8x, just 8x. Yes.
Now would be to the 7.
8x what? What?
This would be 8x to the 7.
Yes.
I don't care what they say about you. You're good. You're alright.
What are they
I'm
saying?
just kidding.
I don't care what they say about you.
Did I see a hand?
So,
Hand.
we have 8x to the 7.
Yeah, but then it says we.
Wait, what?
Oh, duh.
Yeah, yeah.
That's it.
Yep.
Remember,
We have 8x.
Yes, we have what we
And
want.
we have 8x.
So we can skip this step since we have what we want. So just integrate.
So this is gonna be L N 8
X.
This is when they do the second after the.
yeah, now we're just going backwards. So if we start with this, we're gonna end up here, which is where we started. That's why. Because of the nature of the derivative. So we're just completing that circle. Do you see it? Awesome. Slow down. Do you wanna see it? Yes, please. Give me your pencil. Can I write on it?
Yeah, absolutely.
Oh, what?
When she asks you this.
I keep writing this incorrectly. Is it
So
this
when we take the derivative of natural
LN
u, this is where we end up, right?
plus K?
So if we take the integral of this, we should end up
When
where we
you do the
started.
integral, well, plus K was already there.
This and
But
this.
yeah, yeah.
This
No, you did that. This is supposed to be regular U.
What? This?
Because look, this is supposed to be L and U plus K. This is U.
Oh. Yeah,
So what?
you're right. It's not 8x to the 7. It's 8x minus 2. I mean, x 8 to the
3x cubed plus 8.
Yeah, the derivative is what you killed when you take the integral. This guy.
Cubed.
And after, you might have seen him in the hall once or twice. So I worked with him from 11 to 12, and then I had lunch for an hour, because I've been going straight since 8 a.m. And then from morning to oh,
Okay.
dear God, yes, just follow me that. That you can have anytime, yeah, you just follow me upstairs, I'll just like, I'll just give you a box, actually, I have a spare box, I'll just give you one of my boxes.
Do we have what we want?
No, baby, oh, it's going fast. Helena, what's up? What you have is what you want, and then you can skip steps.
It's just,
I'm
we
confused.
just do 9 over 9.
Is what you can skip, make it look like your template, because what you have is what you want.
You know why,
So
right?
step
Because we
four
want
is
9, and
all
we
of
already
this
have x squared.
Maneuvering,
So now it's,
and if you have what you want, you just go straight to the
now
integration.
you,
So is this 5 over 9?
well, yeah, because there's always a little 1 here, and then you circle what you want. You want a 9, and you want an x squared, and everything else, is moved to that side. So you have 5 over 1, wait.
9.
Oh, 5 over 9, duh. Okay, 5 over 9, sorry, 5 over 9. And then the rest is, yep.
You don't have what you want, so what do you need to multiply? Okay, so 5 over 9. So now you have exactly what you want.
Okay, so which one is this?
It's the one with the negative sign, right?
Okay.
So just like up here,
Then
I
it
didn't integrate until I
becomes
had exactly prime.
Remember,
3x cubed plus 8.
no,
Okay.
whatever's on this side goes along to the
So
right.
once you have your
Oh.
template, in this case, this guy, so there was number 4. Once you have that, you just fill in the blanks. So.
5 over 9.
Yeah, I got some. You're working
And
with
then-
control number 4, so now it's locked.
Plus K's are, yeah.
Already there. Oh, we forgot the LN part.
I focus mostly on two, that's what you guys are locked, so.
Okay, so this is gonna be number 3.
Let's get this one out first.
So this is gonna be,
Which integral is it first?
it's number 3.
Okay, circle number 3.
So circle
He was what, 2x? He was which one?
I know, I don't know if you keep them as siblings.
What?
Like if we put x then this, but I guess not.
No, this is a constant, this is different.
So we have
Grab a pen.
x and we want 4x. So
What was it, 5/9 natural log of what?
4.
Yes. Yes. And you remember this,
Four, they're always the
multiply
same.
and divide, that's the,
Okay, so what do I want? I want 4
So the derivative of this
and I want
is gonna be u prime over u.
so then this
And the 5/9 is
comes
gonna
out over
be
here.
u prime.
So then it's just 1 over 4 we divide by 3.
X cubed plus. Okay, these 9s get canceled. And so what you're left with is 5x squared
hold on.
divided by 3x cubed.
Oh, nope, you got it, you got it.
Is that where you started on your problem?
You got it.
So we're just completing the circle. That's all we're doing. And this allows you to process.
Squared.
So I just did this, if I were to integrate it, I would end up right at this. Who else? Got 5 minutes. Let's use it. Elena.
Come on, last one.
Does this become -3?
Yep. Wait, yeah, yep.
U prime.
So which one is the one with the E is 3, right? This one is 3?
Oh,
Which integral did you use?
how'd you get a negative sound? Don't pay attention to me, sir. Yes. We have 5, we want -3. 2 divided by -3. So, we want to clear a circle. Plus K. Right. I always forget I have to keep it. Oh, yeah.
Justin, how do you? Did you get through it? Yeah. How many of you guys got all the way through this one? How do you feel?
I feel decent.
Why is my back row watching videos and not doing their homework?
They already finished.
I just barely got it.
Savages.
Like, that's what this time is for. If you're confused, it's on you, because I've been here the whole time. Here's your homework, guys. 1 through 25, every other odd. Oh, you guys.
Gave us 1 through 27.
Okay, so on the compound interest problem, I want you to treat P like a constant. Just as a hint. Because a lot of you have never seen continuously compounding interest formula before. So I want you guys to treat P like a constant. So N is going to be your variable in this case. You'll see it when you get there.